All right, so we are going to discuss one of the problems we were tackling in class that we didn't quite have time to sort of see through a little bit further. I don't know if I'll do the entire problem with you, but I'll at least recap what we did and sort of give the nudges. So what we were trying to do is prove that a square-based pyramids formula is in fact what you learned in geometry, and we're trying to prove that through our sort of calculus. So step one was identify the base. You made the obvious choice of like, yeah, well, the base, it says it in the problem, the base is the square, so I'll call it that. But then we sort of came across a problem here, which is that when you call the base the square, then when you make your cuts, you're cutting down into the square, and so you'd sort of cut along like so and down, and along like so and down. And while at first you're sort of like, that's cool, like it's a pyramid, or it's a trapezoid every single time. The problem here is that the trapezoid, not only does it like slightly change like dimensions, what happens is the base of the trapezoid is a constant, this base down here, the bottom base, but then the top base and the height of the trapezoid are changing. And so you can totally do it this way. It's just that since you have two sort of changing quantities, things get a little bit weirder. So that's why we sort of avoided this, is that the trapezoid, one, is a little more of a complicated shape than maybe what we could do if we reimagine this. And then secondly is that like there's two changing quantities that we'd have to really sort of figure out how to work out here. But it is possible, and I challenge you, like as a what if, like force yourself. The square is the base. Now how would I go about proving this? It's got a lot of algebra involved, faux show. So that was the thing we said we're not going to do. So what did we do instead? Well, instead what we decided was let's make our let's go with cross sections first. I noticed that if we cut across sort of in this fashion here, cut across, cut across, cut across, every single time we do that, we're going to get a square. And so that's the idea, is that what if we sort of cut it this way? So we sort of changed things up. I think we started in class doing it in a different orientation, but I did mention that you could do it in this orientation. So I'm going to do it because I'm like, I realized after the fact, like I wasn't thrilled with what we were about to do. Okay, so yeah, so if we sort of put the coordinate plane here and view it, it doesn't really matter which way we view it from, either from over here or over here dead on, but then on its side, we would be staring at just a triangle, like so. So I'm going to draw that and that. Yeah, where this point right here is the point h comma 0, so that's the height of this. And then this point here is s halves, sorry, 0 comma s halves, and this is 0 comma negative s halves. All right, and so what we want to do is find the equation for this, each of these lines here. That's the next step. So how do we represent the equation of each of those lines? So let's start with top line. That's going to be y equals, let's see, it goes down by s halves and to the right h, so s halves over h, negative s halves. So that's negative s over 2h when you simplify, x plus, and then the y-intercept is s halves. And then the bottom line is y equals, it's going to be the positive same slope, and then minus s halves. Great. All right, so we got those two pieces of info. So now let's think about how we're going to cut this. So the idea was we were going to cut it this way across. So we're going to cut it this way across. So one of my slices of bread, I'm just going to come in and go, shoo, shoo. There it is. There's my slice. So that's one of these slices here, right there. Like, let's say, imagine like that. Boom, boom, and then boom, boom, and all the way through. So what we're cutting out, so I'm going to draw it over here, is a square. Technically a square-based prism, because it is a slice of bread, so it does have just that tiny little thickness here. Boom, boom. So yeah, this shaded part right here is this part right here that we're pulling out. Okay. So then this length right here, this length here, and this length are equivalent to each other. I'm going to mark that up on the diagram here, since it is a square. And how do we find that? Well, this length, or in other words, this length, is this right here. So I have to represent that distance from the top line to the bottom line. That is going to be, well, hold on, let's check here. This is tiny horizontal, so this will be a dx as the thickness. And then we want this all in terms of x. Yeah, this is going to be some y coordinates, and this is going to be some y coordinate, and I want to find the distance between them. And we want to, so these equations here tell me my y's in terms of x. We want everything in terms of x. All right, so let's see here. It's going to be negative s over 2hx plus s over 2, subtract, and then the bottom line, s over 2hx minus s over 2. Which, when we simplify that, let's see here, we got, that's going to be negative 2s's over 2h's, x, when you add those two things together. And then these ones will be plus 2s over 2. Some 2's will divide, so we got negative s over hx plus s. All right. So now that we have that, we're ready to think about, well, how do I find the volume of this square piece of toast? So let's change color to purple. And we're going to zoom down here. So we're going to go the volume of the piece of toast. Well, first off, its face is a square. So how do I find the area of a square? Well, it's its side length, which we just found to be negative s over hx plus s, but we're going to square that. And then it has a thickness of dx, so times it by that thickness, and there's the volume of the square. But then we want an infinite number of these pieces of toast. And since everything's in terms of x, I'm going to come back over and think about what are my limits on x. So the smallest x could be is 0, so right here. And the largest it could be is h out here. And there you have the setup. I'm not going to finish it out because the rest is some sort of pushing around of algebra, but the idea, what I would do is, like, I would first rewrite this before I would start thinking about the integral or the antiderivative. So think about how you could rewrite this to maybe make your life a little bit easier, and then jump in, noting that s and h are constants, and treat them as such. X is the variable here. X is the only variable in this problem. So as you go through, you're not treating s and h like they're variables. Treat them like you would 2's and 3's. And then the x is the only one that you're thinking about as a variable. All right, I hope that helps. Ping me if you have any questions.